Hello friends, this video on equilibrium part 5 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 4. As I told that the chemical equilibrium is dynamic. What is the proof for this? There has to be proof, right? I'm just telling you it's dynamic, but if you look at let's suppose my glass, if I put some salt in this, if I mix it, it goes off. You keep adding more, it doesn't dissolve. Maybe that the extra salt which you are adding is not even dissolving only. I told that the crystal, the sugar or the salt crystals, the new ones go into the solution, and the some crystals come from solution and becomes crystal also. It happens, as I told. But there is no proof. I didn't give you proof of that. Here's the proof of this. So what we have done is, so let's take two reactions here. So I have N2 plus 3H2 gives 2NH3. This is also equilibrium reaction, reversible reaction. And N2 plus D2 I'll take, and here I'll get 2ND3. D2 is deuterium. So these, in this case, this is my case 1, this is my case 2. So my case 1 is this beaker, case 2 is this beaker. So here I have NH3 in equilibrium, here I have ND3 in equilibrium, and both are in equilibrium now. Both have reached. I have kept these N2 and H2 in one beaker. It reached equilibrium. It has now N2, H2N. So this guy, beaker 1, will have N2, H2, and NH3. Three things. Beaker 2 will have N2, D2, and ND3. Three things. Now what I do is I join this. So what happens is gas comes from this, mixes this, the gas mixes, right? And then again equilibrium is reached. Now since they are already in equilibrium, even if I mix it, what will happen? It will have N2, H2, NH3 from first, and N2, H2, ND3 from second, right? So overall it will have it should have four different, because the duplicates are removing it, 4 different chemical compounds, right? Because it had N2H2, NH3, it had N2D2, NH3, so D2, 4 different, N2H2, and S3, ND3, and D2, right? So we'll have 5, we should have 5 different chemical compounds in this, because they were already in equilibrium, and now also they are in equilibrium, they should not react, if assuming that it is not dynamic. But using spectrometer, scientists have seen that after some time, these the chemical compounds which these two mixed beaker had was NH3 expected, NH2D was there, NHD2 was there, ND3 was there, H2 was there, N2 was there. So H2, N2, these things we expected actually, right? These things we expected. This was expected, but these two we didn't expect. How it came? How NH2D came? How NHD2 came? Why? Because this is dynamic. Even if it reached equilibrium, it was dynamic. It keeps reacting, right? Because see, even if this guy is equilibrium, so NH3 reacted with D2, or ND2 reacted with H2. All these reactions kept happening, and that's why we got these two also. So we're using mass spectrometer. Chemists have found this, and that it proves that the equilibrium is dynamic. Even if the equilibrium has reached, the reaction happens. Forward reaction, backward reaction. Both happen. So in this case, even if the equilibrium has reached, all these reactions are happening. Now since they are in mixture, these reactions also happen. NH3 mixed with D2, and D3 mixed with H2, all these reactions also happen. So now we'll discuss some characteristics of the chemical equilibrium. We have done for the physical equilibrium. Let's do for the chemical equilibrium. So observable property of the system, the pressure, color, concentration, they become constant at the equilibrium, and they don't change after that. These are the observable properties. The property which we observe, those properties becomes constant, right? It is dynamic in nature. The third property is equilibrium can be approached from either side. Example, you have N2 and H2 gives NH3. As I told that you have, let's suppose you start with 10 moles of this, 10 moles of this and 0 mole of this, you will reach equilibrium. Or if you start with 20 moles of this, let's suppose, and 0 moles of this, then also you will reach equilibrium. So it can be approached from either side, either from this side or from this side. Please note, it's a critical thing. Equilibrium can be approached from either of the side. It happens only in the closed system. Physical equilibrium also happens in the closed system. This also occurs in the closed system only. And catalysts, they don't alter the equilibrium. We will discuss more about this. It increases the rate of reaction, but it won't alter the equilibrium because it will increase the rate of reaction both for forward and reverse. It is like this, yeah. I mean, if the rate of formation of this guy is, let's suppose, 10 moles per minute without catalyst, right? 10 moles per minute, and this also, let's suppose, is 10 moles per minute. So the moment you add catalyst, both may become 50 moles per minute. So both the reaction will be fast, right? Both the reaction will be fast, but it won't be altering the equilibrium. So we'll discuss this when we discuss the Haber process here. We actually use catalyst to make it fast, but the equilibrium as such is not impacted. So we discussed a lot about equilibrium, but we have certain doubts. First doubt is, what is the relationship between the concentration of reactant and product in the equilibrium? For example, I have A plus B gives C and D. If I start with 10-10, so in equilibrium, will it be 2288 or it will be 3377? I don't know. What is the relationship? What determines whether it will be 37, 28 or 2.5 and 7.5? You don't know. What are the factors which determine this? Also, can we determine the equilibrium from the initial concentration? I'm told that if I have A plus B gives C plus D is my mixture. If I start with 5 moles of this and 2 moles of this, or if I start with 10 of this, 0 of this, or I start with 8 of this of 0 of this. So in all these cases, with the initial concentration, can we determine what will be the equilibrium concentration? And how can we alter this? How can we tweak? As I told, right, the reason why we are studying equilibrium is we want to understand the property of equilibrium and then tame it to make sure if you want C plus D output, I can get the maximum of this. I can maximize this, right? So that's what the whole purpose of understanding the equilibrium chapter. So the question is, how can we tame it? So we'll discuss. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.